Hey Calc students, I made some extra exam review problems for our test on sections 2.1 through 2.4. I have them here. I'm writing up an answer key, so I thought I'd record myself while I'm doing it, and I can talk through it as I do it. I will probably break this up into multiple videos that are very short that cover just a few problems at a time. Okay, so question number 1. From memory. Oh, and by the way, I'll link the document to this in the description on the video below. And then also it's in our shared Google Drive for chapter 2. So you'll find this there. Okay, so from memory, write both versions of the definition of the derivative of f of x at the point x equals a. One limit should have x approaching a, and the other limit should have h approaching 0. All right, so we just have to have this memorized. F prime at a is the limit as, I'll do the x going to a first. It's the limit as x goes to a of f of x minus f of a all over x minus a. And the limit definition can be written another way. F prime at a equals the limit as h goes to 0 of f of a plus h minus f of a all over h. Okay, you need to know both. You need to be able to use both. Okay, all right, double check. So these are limits at a point. So the result of this is a number. It's the slope of a tangent line. Reminder of some alternate notations. F prime at a is the same thing as the derivative with respect to x of f of x evaluated at x equals a. Okay. If the dependent variable is y, it would be dy dx evaluated at x equals a. Okay, so those are some alternate notations for the same thing. Write down the definition of the derivative is number 2. Write down the definition of the derivative as a function for f of x. This should only have h going to 0. Okay, so f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Notice there's no a's here. Notice where the x's are. Where the x's are in the bottom one, that's where the a's were in the top one, because a is a particular value. That's it. Alternate notations for the derivative. Y prime, dy dx, the derivative with respect to x of f of x, the derivative with respect to x of y, df dx. We don't use that too much, but there's some different ones. Okay, here's an important one. Can you do it? Write the derivative of all 6 basic trig functions from memory. So what have we got? So all 6 basic, really you should memorize, you should also quiz yourself on the product rule, the quotient rule, power rule, constant multiple rule, etc., etc. But let's do the derivative with respect to x of sine of x equals cosine x. The derivative with respect to x of cosine x equals negative sine x. The derivative with respect to tangent of x is secant squared x. Okay, these should be that fast to write down, and the other 3 should be as well. You have to memorize them. Now, what's the reciprocal of sine? The reciprocal of sine is cosecant. What's the reciprocal of cosine? That's secant. Let's do secant first, because we did that one. We proved that one in class. So the derivative of secant x, so the reciprocal of cosine is secant. The derivative of secant is secant x tan x. Okay, I'll put parentheses around this because I'm multiplying 2 functions together. It just makes it clearer and easier to read. Okay, so now what can help for remembering the derivative with respect to x of cosecant x is if you've memorized secant, then the derivative of cosecant is going to have a cosecant cotangent. So if you know the secant derivative, you just change secant to cosecant, change tangent to cotangent, and you make it negative. So this is negative cosecant cotangent. Okay. And so that's that derivative. And then the derivative that I don't think we ever did in class, the two we never did in class was this one and the one I'm doing down here. So I'm just giving you a little advice on how to memorize it. And then the derivative of cotan x is, well, the derivative of tangent is secant squared. So it might not be a surprise that the derivative of cotangent is almost cosecant squared x, but it's got a negative. So notice the negative swap between this one, and notice the switch from secant to cosecant and tangent to cotangent, and notice the connection between these two. Okay, that'll help you memorize those. You should be able to just write the derivatives of these from memory instantly, and you don't need to rederive it. You shouldn't need to rederive it unless you're specifically asked to prove it with a quotient rule or something like that, like we did in class. Okay, that's all for this video. I'll do a few more with few problems off this set.